In this example, we're given an equation, and we have a couple of variables for which we're trying to find the values, a and b. And we also have this addition of fractions, and we notice in the denominator we have some complex numbers. What's nice about the denominators, though, is that these two complex numbers are actually complex conjugates of one another. This is nice because when I multiply them together to get a common denominator, it will actually result in a real number. So no more complex number in the denominator. That's good. So let's go ahead and get to work. So I'm going to get my common denominator by multiplying these two denominators together. So it will be 3 plus 2i times 3 minus 2i. And of course, the process of getting common denominators is I have to multiply this first fraction in the numerator by whatever denominator I didn't have here. So this one's 3 plus 2i, so I'm missing the 3 minus 2i. And the next numerator, which is bi, we have the 3 minus 2i in the denominator, but the factor we're missing is 3 plus 2i. So I'll go ahead and put it there. At this point now, we just have some simplification to work out. So let's go ahead and work through this distribution, multiply that through together, and just kind of see where we are after we do this. So I'll have 3a minus 2ai plus 3bi plus 2bi squared, and that's all over. So 3 times 3 is 9, and then 2i times negative 2i will be minus 4i squared. Let's go ahead and put that guy there. Let's go ahead and simplify a little bit more. So this I squared is really a negative 1, so it'll take this plus sign and make it a minus sign. And the I will go away there, so my real parts look like 3a minus 2b. Okay, that's a real part. And the rest of these have i's that won't cancel. So I'm going to say plus negative 2a plus 3b, and the I kind of comes along for the ride. And the denominator here, this I squared is a negative 1, which will make this minus go to a plus. So 9 plus 4 is 13, and that equals 4 minus I. And the next thing I'm going to do, I'm going to go ahead and multiply both sides by this 13 to get rid of the fraction. So I have 3a minus 2b, and then I have plus, and then I have this imaginary part, which is negative 2a plus 3bi, and that equals 52 minus 13i. Alright, so this doesn't look so bad now. I did a lot of simplification here. So now I have my real parts, which I can set equal to each other. So 3a minus 2b equals 52. And then I have my imaginary parts, which I can set equal to each other. So negative 2a plus 3b equals negative 13. And it looks like what I have here is just a nice system of equations, which I could solve using elimination. So let's go ahead and do that. Let's eliminate the b's. So I'll multiply by 3 up here and 2 down here because they already have opposite signs. And then let's just go ahead and distribute and work our elimination process. So 9a rather, minus 6b equals 156, minus 4a down below when I distribute this 2, plus 6b equals negative 26. The b's cancel, and again, that was by design. So when I add, I get 5a equals 130. So a quick division by 5 shows me that a is 26. That's fantastic. Let's go ahead and plug that back in up here. So I have 3a, so a is 26, minus 2b equals 52. So when I multiply here, I have 78 minus 2b equals 52. Subtracting 78 from both sides gives me negative 2b equals what? Negative 26. So a quick division gives me b is 13. So from this original equation, where we had some fractions and lots of stuff going on up here, I was supposed to find values for a and b that made this equation true, and that's exactly what I did. So a is 26 and b is 13.